look at finding vertical asymptotes. The way you know vertical asymptotes in these rational expressions is you reduce the fraction and then see what makes the denominator 0. But now we're not only going to find vertical asymptotes, we're going to find out is it approaching infinity or minus infinity on each side. Okay, so the first thing I want to do is I want to find the limit as x approaches 1. I'm talking about a two-sided limit here. So that's going to be my limit of x. Now I'm going to go ahead and factor this, save some time. I know if I put 1 in, I'm going to have a 0 in the denominator. So let's go ahead and factor. That's x minus 3, x minus 1 over x plus 1, x minus 1. One of the techniques that we used when we had 0 in the denominator is we tried to factor and reduce the fraction if we could, because that common factor of x minus 1 is creating a hole in the graph. So the limit there still probably exists. Since it's just a hole, we see that common factor. So now this limit will be the same as the limit of x minus 3 over x plus 1 as x approaches 1. And now it's a rational function. The denominator's not 0, so I'm just going to go ahead and evaluate. So I'm going to have negative 2 on the top, 2 on the bottom. My limit's actually negative 1. So what that means is I do have a limit as x approaches 1. That means 1 is not a vertical asymptote. It has to, for a vertical asymptote to exist, the limit has to be infinity or minus infinity at that value. So it's not a vertical asymptote. Okay, so now let's look at the limit as x approaches negative 1. Again, at negative 1, you see the denominator is still going to be 0. The difference is at negative 1, we don't have that common factor of x plus 1. So that's not going to go away when we try to take the limit. So first thing I want to do is I want to look at this same limit, and I'm going to go ahead and reduce it down, because if x is negative 1, I can get rid of the x minus 1s because they're not 0 in that case. So I'm going to look at the expression x minus 3 and x plus 1 as x approaches negative 1 from the left side. Okay, so now what I'm going to notice here is if I put negative 1 into this expression, it's approaching negative 4. Now the denominator, as x approaches negative 1, the denominator is approaching 0. Okay, so now if the denominator is approaching 0, the top's approaching negative 4, it's relatively constant, then I know that this quotient is going to go to infinity or negative infinity. So now, which is it? Look at which side you're taking the limit on. I'm approaching negative 1 from the left. So I'm looking at something smaller than negative 1, something down here, so negative 1.1. Put in negative 1.1. I know the top's approaching negative 4, the bottom is going to be negative. So since the bottom is negative on the left side, and I know it's going toward infinity or negative infinity because the top's relatively constant, the bottom's going to a 0, and since it's negative on the left side, then I know this is going to be a negative infinity. Okay, now looking at taking the limit on the right side. Again, I'm going to be looking at the reduced fraction x minus 3 and x plus 1 as x approaches negative 1 on the right side. Put in a number a little bigger than negative 1. Something bigger than negative 1 up here, maybe negative 0.9. So I'm just going to use negative 0.9 as my test number. Again, the top is approaching negative 4, because we're approaching negative 1. And the bottom is going to be a negative 0.9 plus 1 would be positive 0.1. So it's approaching positive 0.1. The bottom's approaching 0. Top's relatively constant. I know this is going to be infinity or negative infinity, but the bottom here is positive. The top was negative, so that's going to be a negative infinity. Now I think I did the one before that, just caught my mistake there. This one, I didn't take into account the negative 4 on the top. The bottom, when x was negative 1.1, is negative 1. The top was a negative also, so that was actually going to be a positive. The bottom was negative on the left side, but so was the top, so that's going to give us a positive infinity. So that's how we find a vertical asymptote. We do have vertical asymptotes or a vertical asymptote at x equal -1. And the way we know that is because on one side or the other of -1, we got infinity for, or minus infinity for the limit. So x equal -1 is a vertical asymptote. And if we wanted to graph this now, you know, at 1, we know the limit was -1. Okay, so what that meant was I had a hole here where the y value was -1, so maybe it was going to look something like, maybe something like this. But then as x approaches -1, that's a vertical asymptote, and I know approaching it from the right side, it's going toward minus infinity, and we can see here that's probably what's going to happen. I didn't quite get that drawn over enough. It's probably going like that. And then on the left side of -1, we know we're going up toward positive infinity. Okay? And we can see, if you use some of your algebra, you should be able to see that the horizontal asymptote is actually y equal to 1, which is that limit at infinity also. And so we would have had a horizontal asymptote here. And so that's what's going on with that graph. Okay, one more thing. I'm going to look at one of the trig functions. Now, if you know the graph of cotangent, I always tell my trig students to memorize cotangent. It has a vertical asymptote at x equals 0, and then again at x equal pi. And then cotangent is the one that's decreasing. It goes like this. And so then over here, it's going to be repeating the same behavior, so it's going to look something like that. Okay, so now if I want the limit as theta approaches 0 from the right side, so we're approaching 0 from this side, what's cotangent doing? Well, you can see the cotangent values are going toward positive infinity. The limit from the left side, so coming this other direction, the y values are coming down here, and they would be approaching negative infinity. Now you can see that if you think of cotangent of theta, if you remember your trig identity, it's cosine theta over sine of theta. And if theta is approaching 0, the top would be essentially 1. It's approaching 1. And the bottom is approaching 0. So again, we have the top is fixed, the bottom is approaching 0. We know it's going to be infinity or minus infinity. If theta is approaching it from the positive side, then that means that sine of theta is positive, so it would be positive infinity. And if theta is approaching 0 from the negative side, then we know sine of theta here is going to be negative, so we'd be approaching negative infinity. So that's how you could do the trig functions. You could look at it as a quotient of sine over cosine, or cosine over sine for cotangent, or you can draw the graph of cotangent. You can see it graphically as well.